Hey guys, and welcome back to a new video. In this video, I will show you how you can track a user's location in Android in the background using a foreground service. So a foreground service is usually what you use for that. So you will show a notification that the app is actually active, because that comes with a lot less restrictions when it comes to tracking the location of a user. It also works to do this in a background service, but then you need an additional permission. And in my experience, it's just not so common that you really need to do this without the user being aware of that. So the app that we will build here is a simple UI here with a start and stop button that will, well, start and stop location tracking. If we click this and take a look at our notifications, wait a little moment, then you can see here we started location tracking. This is of course not a real location. This is just the last 3 digits of my current location, because I don't want to show you my real location. So I just show you that, yeah, the location tracking is working here, and yeah, the last digits are actually changing very insignificantly. So the actual location stays the same, but of course the last digits might differ a little bit. And also if we minimize the app, then the location tracking will still go on. So let's jump into Android Studio here, an empty Android Studio project. All I did was to add these location services, this permission here, not permission, this dependency, to actually get access to the location services and everything we need to be able to track the user's location. And then we can actually start to go into our manifest, because we need to add a bunch of permissions here. First of all, we want to add a user's permission, internet, because the location might be fetched using the user's internet or GPS. We need a permission for access course location, which is used to fetch the user's rough location, so it's a little bit inaccurate. And we want to have access find location, which is used in combination with that if you also want to fetch the user's more exact location. And one more permission here is actually Foreground Service, since we want to use a foreground service here, a service in Android that pretty much just runs in the background, but the user is actively aware of that by, that we just show a notification. So now that we have all of our permissions, we can close this manifest again. And you wouldn't be on my channel if I wouldn't show you how to also properly integrate that here into an existing architecture in a way that scales, because I think otherwise that might still be hard for some of you if you want to actually build something real with what you learn here, but you don't really know how to integrate that into your architecture. And that's why I will show you a cool abstraction that I typically like to use when I implement location tracking. So we will build an interface here that abstracts out these location updates, and I will call that location client. Make that an interface, and in here we simply have a function get location updates. We want to be able to pass an interval, so how often we want an update, interval. And this will return a flow from coroutine's flow here of type location. So this will effectively give us a flow that will have an emission that will emit a location every time there is a new location that we fetch. And we also want to have a little class here, which I will call location exception. If something goes wrong, for example, if the user does not have location permission, or if GPS is disabled or something similar. So here we want to pass a message, and that's just a normal exception. Cool. And that's already everything for this abstraction, so we can use this without actually giving away any information about implementation details. So you could also easily use this in a view model, because the actual implementation will need the context, which you don't want to use in a view model. But since, you have an abstraction and then an implementation of that, you could also easily just fetch these location updates in a view model and update some kind of state or so. So it's really convenient, easy to deal with. Let's go to our root package, and I'll write the actual implementation of this location client. I will call this default location client, make that a class, and it will implement our interface that we just declared. It will take 2 constructor parameters here. On the one hand, as I said, the context. And on the other hand, it will use a client, which is a fused location provider client. That's a dependency that comes from our Gradle dependency that we included, and it's used to actually get the user's location. So that's the actual Android specific implementation of a location client that we can use to actually get the user's location. And in here we can say Control I, implement this get location updates function. And here we, of course, now need to return a flow. And the first thing I want to do here is to check if the user actually accepted location permission, because these are considered dangerous permissions. So the user explicitly needs to accept these. So it's not as easy as with just adding an internet permission that we don't need to get some user's approval or so. But yeah, we actually need to show a permission dialog that asks the user to actually grant access or give our app the permission to fetch their location. So what we want to do is we want to actually go to our root package and create a little context util or context extension package file, and rewrite an extension function for context, has location permission, return boolean, and here we can return context compat check self permission, pass this as the context, and the permission we want to check is manifest permission access course location, and if that's equal to package manager permission granted, oops, we know that we have this permission, but we also want to check for the other one, which is access find location. So we put this here, swap this out with access find location, and then we're good. Now we have a function to easily check that in our location client. And what we want to return here is not just a normal flow like this. No, we want to return a callback flow. A callback flow is used if you actually have a callback that you want to transform into a flow. So you have some callback that gets fired over and over again, like our location callback that we will have here, that gets triggered when we fetch a new location. And we want that as a flow because flows are just cool to deal with and very convenient. So we use a callback flow. And a callback flow is also very useful if we actually want to model some kind of callback that has a life cycle. So for these location updates, that's the case because we need to tell our location client, this Fused location provider client, hey, now start to fetch location updates. And then there's also a function to actually say, okay, please now stop to fetch the user's location. And with this callback flow, we can very easily kind of model this behavior using coroutines so that we can collect this flow. But as soon as we stop collecting this, for example, when the scope is canceled, when the user navigates away and view model scope is canceled or so, then we can automatically call this function to stop getting location updates. You will see how convenient and nice that is. First of all, I want to check if context has location permission. If that's false, we want to throw an exception, our location client.location exception, and say, okay, missing location permission. If that is the case, if the user has location permission, the next thing we want to check is if they actually are able to fetch their location. So if they have GPS enabled or the network provider, so to fetch the location using the user's network, we can do this using the system service location manager, which we can get like this, context.getSystemService, context.locationService, and we cast it as a location manager. We can then say val has GPS, or let's say is GPS enabled. And that's equal to location manager is provider enabled, location manager GPS provider. We do the same for is network enabled. And we simply swap out GPS provider with a network provider. And if both these options are false, so if we don't have GPS enabled and we don't have the network provider enabled, we also want to throw an exception. So throw location client, location exception, and we say GPS is disabled. Cool. So at this point, we can be sure that we can actually fetch the user's location. So what's next? Next up, we need to create a so-called location request where we just define, hey, this is how often we want to fetch the user's location. This is how accurate we want it to be, and just some further configuration. So val request is location request from Android location here, I think at least. And we say builder. Actually not. I think it is the other one from this one, com, Google, Android, GMS location. We say that create, yes, that's the one. And now we have a typical builder pattern where we can say set interval, which is our interval we passed, set fastest interval. So there could be a little bit of difference, or these intervals could differ a little bit. I mean, so this is the slowest interval, or the average interval, you can say, and there is a fastest interval where you can say, okay, it should really not be faster than this one. I will just pass the same here, which will later on set to 10 seconds or so. We can then also say, do we have accuracy? Not sure. I actually didn't do that in my preparations. Doesn't matter. We can set the priority. We could also just say build or create. Oh no, we actually don't. We already get a location request here, so we don't need to do anything. And now we can use this location request we built, and we can say we create a callback. So location callback is equal to object location callback. And here we implement the on location result function. This function will now be called whenever our fused location provider client fetches a new location. So we want to rename this with result, and this result now contains a locations list, and the last element of that locations list is actually the new location that was fetched. So locations.last or null, if that exists, so if there is a last entry, which is our location, we actually want to notify our flow and send something in that flow so that we get that location that we just fetched. And we can do this by using the launch and then call send, since then we can send a location here in our callback flow. Yes, simply the location we just fetched. Yeah, and that's how we specify a location callback. This will now be called for every single location we fetch. And we, of course, right now don't do anything with that callback. And that's what we will use our location client for. So location, how did I call it? Just client. Dot request location updates. The location request is our request. The callback is our location callback. And we need to pass a looper, as you can see, which is just looper get main looper. And we do get a little error here because it doesn't recognize that we actually check for the permission here in our extension function. So we can just get rid of that warning by pressing Alt Enter and adding the suppress lint annotation. And then we get rid of that warning. And now all we really need to do is, since we are inside of a callback flow, and as I said, we want to use this if we have some kind of callback with a lifecycle, since here we start to request location updates. And when the flow actually stops, so when we stop collecting, we automatically also want to say that we stop getting the location updates. So what we can say is, we can say await close, which will block the flow until it's closed, until the coroutine scope is cancelled or the job it's running in. And in here we can say client remove location updates, and we pass our location callback again. And that's effectively how we can transform our location callback into a very convenient class with a single responsibility, with a nice abstraction, which we can now use wherever we like in our code. The next step is to actually set up our service, because we of course now want to fetch the location not just in the foreground, but also in the background, or rather only in the background in this tutorial. And for that, in Android, we use a service, which simply keeps on running when we minimize our app. And especially if we make it a foreground service, which comes with a notification, so the user just knows that there is a service running, then the app is still kind of considered in the foreground. That's why it's called like that. And therefore, we don't have these typical restrictions we have with location tracking in the background as we have with the normal services. Because if you want to do that in a normal service so the user is not aware of that, then you would need to add an additional permission, which is access background location. This one would be needed for, I think, at least API level something, I forgot it, but you need this, and you also need to request this. I think the user actually needs to go to the app settings and toggle this on, and Google Play will also only approve it if they see a legitimate reason in actually fetching the user's location in the background without them knowing about that. So we don't want to do this for that reason. Usually you're fine with using a foreground service. For example, if you want to build a running tracker app, which I also have on my YouTube channel, then the user of course knows when they are currently running, and they know that it's normal that the app tracks their location while doing so. And then the notification would simply show currently tracking your run or so they will know about that. Let's create our foreground service here, call that location service, and make that inherit from service. Then we will need to implement this on bind function, which we can simply return null in, since we don't bind our service to anything. And let's then set up some helper variables. On the one hand, we want to have a curtain scope. I will implement a service scope here, which is simply bound to the lifetime of our service. And we can create that using curtain scope, supervisor job, plus dispatchers IO. Since we deal with IO things here in our location service, tracking the location is an IO operation in my opinion. Not just in my opinion, it is like that. And using supervisor job just makes sure that if one job here in this scope fails, then the others will still keep running, which is of course what we want in this context. And we want to have a private late-ended variable, location client, which is our location client abstraction we just created. Since then in onCreate, when our service is created, we can say location client is equal to our default location client. And usually I would use something like di here, but yeah, just for the sake of simplicity, I don't do this in this tutorial. Here we want to say the context is just this, or we can pass the application context. And the client is location services, get fused location provider client, and we also pass our application context here. And the way this now works, if we want to communicate with this service, so if we have our activity and we click our start and stop button, we of course need to send some information to our service to update our notification or to just start the tracking. To do that, we want to define two actions. In a companion object, action start, which we send to the service if we want to start the tracking. And we want to have action stop, which we call when we want to stop this tracking. And then there's a function for services called onStartCommand, where we can check what the action actually is. So this is now called for every single intent we send to the service. And if these intents actually have an action, so when intent.action is action start, then we want to start our service. And if it's action stop, we want to stop our service. And those are two functions we will now implement. On the one hand, private function start. Then we want to have a private function stop. And we actually also want to override on destroy. So when the service is destroyed, in that case, we want to make sure that we cancel our curtain scope. And when we cancel this, since we now use a callback flow in our default location client, and we launch this flow in our service scope later on, then as soon as we cancel the scope, so as soon as the service is destroyed, we automatically also stop tracking the location. So there can't be any weird leaks or so because you forget to actually call this remove location updates function. This really can't happen with this nice abstraction we implemented here. So let's start to implement our start function. And as I said, since we want to use a foreground service here, which comes with a notification, we of course need to show this notification and create it first. So what we want to do is we want to have a notification is equal to notification compat.builder. We pass our context and we pass a channel ID, which I will just choose location here. We want to set a content title, which is the title of our notification. I will say tracking location. We want to set a content text, which I will say, okay, the location is actually, let's just say null by default. So we don't have a location initially, of course. We want to say set small icon. That's what a notification needs. I will just set it to the launcher background. Just a green square, doesn't matter here. And we say set ongoing to true, so we just can't swipe it away. And we then want to say start foreground to, just make sure to make this a service a foreground service. We want to pass an ID, make sure to pass at least one here. And for the notification, we say notification.build. However, that of course now did not start the location tracking and actually updates our location, so we don't see this null here. How do we do that instead? Well, we of course now want to also launch our callback flow together with the start function. So right here, we want to say location client, get location updates. The interval, let's say, is 10 seconds. So every 10 seconds we get a location update. And we can say, first of all, catch. So if we get any exceptions, we could print these or simply say print stack trace. And then we can say on each location that we get here, we simply want to update our notification, of course. So we want to say, or at least I want to say, you don't need to do that here. My lat is simply location latitude toString take last 3. So again, I just take the 3 last digits of my location, so you don't see my whole location. And I'll do the same with the longitude. Again, you can simply use location.latitude and longitude here directly, and you will get the full location, of course. And then we can say we actually construct an updated notification. It's equal to our notification dot set content text. And here we simply say location is lat long, just like that. And we can then say we actually get a reference to our notification manager up here, which is get system service context, notification service as a notification manager. And we can now use that to actually update our existing notifications by simply calling notification manager.notify with the same ID we chose below. And we pass updated notification.build. Cool, so that's really what we want to do on every single location update. We of course now need to make sure that we launch this in our service scope, and that will effectively bind this callback flow, this function returns, to the lifetime of our service, since we cancel our service scope in onDestroy. And that should be it for the start function. We now need to implement the onStop function, which is very simple. We can simply say, on the one hand, stop foreground, pass true to make sure we remove the notification when this is stopped, then calling stop self to actually stop the service. And that's pretty much it. Cool, so now that we have our service ready, we want to go to our manifest. Since we actually need to register our service here, we want to say service, location service, and what's very important now is that we say foreground service type and we set this to location. Otherwise, Android won't allow you to actually track the user's location in a foreground service if you don't actually explicitly mention this. I've had a lot of pain with that in the past, that I didn't add this and it didn't work, but with that it works. And we now want to create an application class, since if we want to show notification, we also need to create a notification channel in which we send these notifications. So we say location app, for example, make that an application, and here in onCreate, we can create our notification channel. And we only need to do that from Android Oreo onwards. So we've built version SDK int is greater than or equal to build.version codes O. Then we want to do this and we say val channel is a notification channel. The ID is the same as we actually chose here in our location service. I'm just too lazy now to make it a constant. So just make sure you have the same as you mentioned here. Then the name is location as well, for example. And the importance is notification manager importance. I will choose low here. You can choose high, then it will appear higher at a higher rank in your notifications. But this will also come with notification sounds. So every time there is a new notification update, this will make a sound. You can disable that, but I won't do that here. I'll just choose low. And then we want to get a reference to our notification manager. So again, we can say get system service, context notification service as a notification manager. And we can then say notification manager, create notification channel, and we pass our channel here. We then go back to our manifest and we make sure to register this application class here under the name attribute and add this location app. Cool. The last thing we need to do is to go to main activity and actually add our 2 buttons and make our permission request. I will do the easiest permission request possible here. So we just assume the user accepts these permissions and grants them. Of course, if you have a real app, then you need to do some more fine-grained permission handling here and also handle cases where the user declines that. I won't cover this here because I don't think it's really necessary for the sake of this tutorial if you want to learn about location tracking. So we can just say activity compat request permissions, pass this activity, pass an array of permissions we want to request, and that's simply manifest permission access course location, and access find location. And the request code is simply 0 here. And then here in our compose UI, we can add a column. Let's say we make that fill our whole size. And here we add 2 buttons. That's the first button. We can give it a text of start, adding a little bit of space in between. Let's say 16 dp. And then we have the same button down below. And just swap this out with stop. Cool. So now the last thing we need to do is to actually fill in these on click listeners. And what do we want to do here? We of course want to launch our service, and we simply do that by sending an intent to our service so that we trigger this onStart command function with an intent that has the action start or stop, depending on what we want to do. So we say intent, pass the application context, and pass the service class. Location service class at Java, and we can say apply, and we say the action is location service action start. And then we simply do the same for our onStop button and simply swap this out with action stop. And of course, we also need to say start service to actually send this command to the service by saying this and here actually as well. And don't confuse this here because this is action stop and this is start service. The start service function will actually just send this intent to the service and it will then check, okay, it's actually action stop, and the service will then call the stop function here. If we launch this and try this out, check that here. We first of all want to say while using the app to grant permission. We could have centered these, of course, but let's not care about that now. Clicking start and waiting a little moment. Maybe it doesn't work now, but after relaunching the app, it always worked. I'm actually not sure why. Also why there's sometimes a little delay. Okay, like right now it works. You can see the notification is actually showing. It is tracking my location and showing that in the notification as well. And that will now also work if we actually minimize the app. Take a look here, then this will actually keep on running and running and running. A foreground service is pretty much an infinite service, so until you stop it, at least for some Chinese devices, some of these like to kill foreground services in some rather rare circumstances. But usually a foreground service is used to keep it running as long as you want. If this video helped you to actually get better at Android, to learn about this topic, and you like this, then consider subscribing to this channel, because then you will get 2 of such videos every single week. And maybe we can even reach the 100,000 subscribers at the end of this year, which would be amazing, and I would be very happy about that. So if you're not a subscriber yet, do subscribe now, and I wish you an excellent rest of the week and enjoy your day, and see you back in the next video. Bye bye.